All right, in this video, we are going to complete our work for tonight on section 3.2 and 3.4, talking about subtraction. So let's look at the definition of subtraction. For any whole numbers a and b such that a is greater than or equal to b, that's important, a minus b is the unique whole number c, and b plus c equals a. So does the use of the word unique here imply that whole numbers are closed under subtraction? We talked about that in the video about properties, about uniqueness being part of the idea of closed. Okay, so let's explore that just a little bit. Suppose I take two whole numbers and I subtract them. So let's do 4 minus 8. That gives me -4, which is not a whole number. So the whole numbers are not closed under subtraction unless they have this restriction. Notice that the a value that I have here is not greater than the b value. So if I put it with a minus b, where a is larger, then I do get something in the whole numbers. I'm going to get that to be equal to +4, which is a whole number. So with this restriction, we could say they're closed, but in general, the whole numbers are not closed under subtraction because I can't take any two whole numbers and subtract them and get a whole number, as I've illustrated right here. Okay, remember how in our addition video we did some base 5 numbers to see what that was like for our students? Let's do the same thing with subtraction. So if we lived in a base 5 world and we were kindergartners and our teacher was asking us to do base 5 3 minus base 5 1, we might hold up 3 fingers and put 1 down, and then we would get 2. The answer to 3 minus 1 in base 5 is 2 in base 5. But how about 11? 11 says I have one whole group of 5 and one more. So maybe I would hold up one whole hand and one more. And then when I put down 1, I would get 10. But if I put down 2, I would get 4. Because remember, there is no 5. So that one whole hand in base 5 is 1 0 because it's one whole group of 5 and 0 ones. And so if I take away just 1, I've still got 10, but if I take away 2, then I've got 4. Okay, let's apply that same kind of logic to our kindergartners, to our first graders, as they are learning the different ways of subtraction. So we can model this several different ways. The first one is the takeaway model, which is the opposite operation of the add to model that we did before, or the join to. So in this case, we have a total amount. Our friend Carl has 8 toy cars, and he shares some with his friend Trey. Those 3 cars that he shared are taken away from his original amount. That's why this is called the takeaway model. And then the question is, how many toy cars does he have now? Well, we might choose to model that with our linking cubes. And so a student would put out 8 total linking cubes to represent the cars that Carl had to start with. And then he would take away the 3 that he shared with Trey and count what was left and come up with an answer of 5. All right, another possibility is what we call a missing addend. I don't know if you remember from the standards, but in first grade, it asks us to understand subtraction as an unknown addend problem. Okay, let's see what that means. Well, if I'm giving my first graders the problem 8 minus 3 equals question mark or equals box in this case, we might think about that as 3 plus something equals 8. So remember our definition of subtraction. Let's look back at that really quickly. If A minus B is equal to C, that implies that B plus C must have been equal to A to begin with. That's our missing addend approach. So in this one, instead of our student thinking about it as 8 minus 1 equals, 8 minus 3 equals box, we might think about it as 3 plus what is going to get us to 8. And the answer to that question would be 5. So this student, if this student were modeling by counting on his or her fingers, he might hold up 3 fingers and then count 1, 2, 3, 4, 5 more fingers and add up with 8 total. That's equivalent to holding up 8 fingers to start with and then putting 3 of them down and ending up with 5. So I've made the observation here that 8 minus 3 equals box and 3 plus box equals 8 are in the same fact family. So when my kids were in first and second grade, they spent a great deal of time talking about these fact families. And the idea was if we can group all of these things together in the student's mind, it will help them to make some connections. So they have to memorize at some point in first or second grade that 5 plus 9 is equal to 14. Well, once they've memorized that one, because 9 plus 5 is the same fact family, they've automatically got this one memorized. And then if they learn about the missing addend, they know that 14 minus 5 is 9, and similarly, 14 minus 9 is 5. That is a fact family. It's all the ways I can combine 5, 9, and 14 to make a true equation. So once students memorize this first one, 5 plus 9 equals 14, at whatever point in the year the teacher gets to that, they sort of automatically have these other three, but only if the teacher makes it plain to them. So at least at first, you're going to want to make those fact families obvious to your students. And then hopefully they'll catch on to the fact that, well, if 6 plus 7 equals 13, then I know 7 plus 6, I know 13 minus 7, and I know 13 minus 6. And they'll start making those connections as well. You just have to make them first very obviously so that your students can begin to make them on their own as you move through the numbers. Okay, so let's go back to our friend Carl and his friend Trey. So in this case, Carl had 8 cars. He shared some of them with Trey. We don't know how many. All we know is that he had 3 left at the end. So the question is, how many did he give Trey? So I might start off by putting down 3 blocks and then counting upwards until I get to 8. I might put block, 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 block until I get to 8. And that's going to, the extra blocks that I put down, that's going to be the answer to the question. That's going to be the 5 cars that Carl shared with Trey. All right, in addition to doing that with blocks, our students might choose to do that with a number line. So here's the 8 cars that Carl had. Here's the 3 he has left, so this extra amount right here, that must be the answer. That must be how many he gave Trey, and so your student could count how many spaces it is between here and here and end up with the answer of 5. Okay, let's look at a comparison model. This is a good time for looking at how many more or how many fewer, how many greater, how many less, something like that. And a good idea for that one is a strip diagram. So this is your total number of things, whatever those things happen to be. This is the 3 things that you know somebody has. And the question is, how many more things? What's the difference between the end of this strip and the end of this strip? That's the answer to the question. And you can see how that is sort of modeled right here with our number line. So here would be the long strip. Here's that first short one. And then the how many more might be right here. That doesn't fit with this particular word problem. I just wanted to illustrate how it fits the same way as a strip diagram would. So a word problem that would fit with that. So Juan has 8 blocks. Susan has 3 blocks. And the question is, how many more? That's my indication that I'm looking at a comparison. How many more does Juan have? So what a student might do is line up Juan's blocks, line up Susan's blocks directly underneath them, and then there's the extra blocks that Juan has. There's the how many more. You can see how this could be modeled as a strip, right? If I put those 8 blocks together and those 3 blocks together, the strip that would fit right here is 5 blocks long, which would be the answer to the question. Okay, let's look at another number line. Let's go a different way on this one. Instead of thinking about it as a missing addend, let's look at it as an actual subtraction problem. So if our friend Antoine has 5 pieces of candy and he eats 3 of them after lunch, so the question is, how many does he have left to eat at break later that afternoon? Okay, so think about what this would look like on a number line. Here's the 5 pieces of candy that Antoine bought at the beginning of the school day. Here's the 3 pieces he already ate. So you can see how I'm removing those from the 5 that I had. And the answer is right here. The answer is the distance between this blue bar and this blue bar. That's going to be represented by 5 minus 3, and I can see that that is 2 spaces wide. So remember how when we did addition, we talked about putting the end of one number line on the other number line with no gaps, no jumps? And so that's going to be the same kind of thing here. I put my first part of the number line model, and then I line that up exactly in the same place. No jumps, no gaps, no overlaps. And I'm going to go backwards. And then the answer is going to be right here. It's the distance between where I started and where I ended up. Okay, just like before, when we talk about our introductory algebra ideas with our young students, we're usually not using letters. We're usually not using X like what we're used to in algebra, but we use symbols, we use boxes, we use circles. 12 minus something equals 4. Maybe this is a true statement, maybe this is a false statement. If that something is 8, then 12 minus diamond equals 4 is true. If diamond is something other than 8, let's say diamond represents 10, well, 12 minus 10 does not equal 4. So in that case, this would be a false statement. A lot of times in middle level classes, this is something that they're going to do to help them understand about substitution. And they're going to say, well, what if this symbol equals this number? Is it true or is it false? Is it part of the solution or not part of the solution? For your younger students, you would usually use symbols like this. For your middle schoolers, often you're going to be going to X and Y at that point. But the same idea is true whether you are a first or second grader or whether you're a seventh grader. You're still trying to figure out, in order for this statement to be true, only certain numbers can be substituted in here. In this case, only one number, and that is 8. So 8 would be the solution to this. Any other number that I might try to put in there is going to make it false, so it would not be part of the solution. Okay, as we're wrapping up, let's remember our assignments that are up and coming. Your homework 3.2, 3.4, sorry, parts 1 and 2 are both due on the 18th. We have covered most of that, but not all of it. So do as much of it as you can, and then after our next class, you'll be able to go back and fill in the blanks and finish up just those last couple things before it's due. On Tuesday, the 16th, is Wellness Day 1. So that's why we won't have class that day. And in fact, you'll have other videos posted for Thursday, the 18th, which will finish up this section and allow you to complete the homework. So get as much of it done between now and then as you can. If you're planning on retaking the procedural fluency test, continue working on that practice, whether you choose to redo the assignments in Blackboard in my math lab, or whether you choose to do the assignments in Blackboard, or whether you choose to talk to me during office hours, or perhaps you're going to go to the Math Tutorial Center and ask them to make you up problems, but just continue working on practice problems so that when you take it next time, you're going to get the score that you want.